How can we develop a business layer for a Spring application using the TDD method? In this video, we are going to achieve this. In the previous video, we developed the persistence layer using integration testing. You can access that video from the card at the top of the screen. This time, we are going to use unit testing when writing business logic. First, we should create a content command interface under the command package. This command object will facilitate communication between the application layer and the domain layer. We should also create a command handler interface in the service package, which we will use as a Spring service. Next, we will create a content service class to implement business logic based on the command objects. This class must implement the command handler interface. Finally, we need to add the service annotation above the class declaration. Now we need a test class to verify business behaviors. To generate a test class, press Alt Insert, then select Test. A test class will be created under the test package. At this point, we are ready to start coding the domain layer logic. Our first domain service behavior is the create content behavior. The application layer sends a create content command with username and text fields. The domain layer processes this command and produces a content object with a URL and creation time. This content object is then sent to persistence layer to be stored in the database. The persistence layer generates an ID, saves the content object in the database, and returns it with the newly created ID field. The domain layer then checks the ID field of the returned content object. If it is not null, the domain layer returns a response containing the URL and creation time to the application layer. This is our create content behavior. You can access the source code from the Tanho Labs GitHub account. Let's start coding. First, we need to create a test method named should create content when create content command received with username and text. We define our create content command instance in the given section. As you can see, we don't have a create content command class yet. So let's create it. This class must implement the content command interface. Define the class fields. Generate its getters and setters. Return to the test class and import the create content command class. Now set the command objects fields. When we process this command in the domain layer, we will receive a create content command object as a response. Then we assert that this response object is not null. Assert that the username in the response is equal to username in the command. Assert that the text in the response matches the text in the command. Assert that the URL is not null. Finally, assert that the creation time is not null. This is our content creation behavior. When we send a create content command with a username and text, we expect to receive a URL and a creation time from the domain layer. Go to the content handler interface. Create a method named saveContent, which takes a create content command object as a parameter and returns a create content command object. Now go to the content service class and implement the saveContent method. First, we need to generate a URL and a creation time. To create a URL, we need to create a Java class named URL generator. In this class, we define a static generate URL method. This method will create a random URL for our contents. Next, we need to save this data into the database. To achieve this, we must create a content object. I will add an extra name field to indicate the execution layer. We will send this object using the persistence service interface. We developed the persistence service layer in the previous video, which you can access from the card at the top of the screen. We need to inject the persistence layer interface using constructor injection. Using the saveContent method from the persistence service, we send the content object for processing and receive a response as a content object. Now we need to check the ID field of the returned content object. If the ID is null, throw a runtime exception with the message persistence error. If the ID is not null, set the URL and creation time fields in the command object and return it. This completes our content creation behavior. Now let's go back to the test class. In the content service test class, we need to invoke the command handler to run our test case. Define a private command handler object. We need to create this object before executing each test method. To achieve this, we define a method annotated with before each. Inside this method, we instantiate a command handler object as a content service. However, we encounter an error because the content service class requires a persistence service object. Since we used constructor injection, we need to provide a persistence service instance. At this point, we could invoke a persistence service object from the persistence layer, but this would exceed the domain layer boundary. According to unit testing principles, we cannot go beyond the domain layer. Instead, we can create a fake persistence service or use mocking. I prefer to use a fake implementation to avoid mocking hell. To do this, create a new adapter package under the test domain directory. Inside this package, create a fake persistence service Java class. This class should implement the persistence service interface. Go back to the test class and pass an instance of fake persistence service into the content service constructor. Process the command, add the saveContent method from the command service into the save behavior. Our test class is ready to run, but before that, we have one more step. We need to implement the save behavior in the fake persistence service class. If the username of the content is equal to test username, return the content with an ID. Otherwise, return the content with a null ID. We do this to observe the domain behavior when a persistence process fails. Go to the test class and run the test. Yes, we are successful. But how successful? To measure this, we can run our test with coverage analysis. Click on the run icon and select run with coverage. According to the result, our test covered 93% of lines and 50% of branch. When we inspect the content service class, we can see the uncovered lines of the code. Some lines are highlighted in red, meaning our test method did not cover them, but we want to reach 100% test coverage. To achieve this, we need to create a new test method. Go to the test class and create a new test method. Should throw exception when persistence error happens. Inside this method, define a create content command instance. Process this command using the saveContent method. Assert that the throwable object is not null and that its message matches the message in the content service class. Go to the class declaration and run all tests with coverage. According to the result, we have achieved 100% test coverage for the domain layer without using mocking. You can apply this method in your own project. I will increase the video speed to avoid wasting time. You can find all the domain layer code on the Tanhu Labs GitHub page. If you like this video, subscribe to Tanhu Labs channel and don't forget to hit the like button. We used unit testing to observe our business behaviors. We focused on testing business behaviors, not just individual methods. For the save content method, we create two different test methods because it involves two behaviors, success and failure. Always focus on your business behaviors, not just your service methods. This mindset will enhance your test development skills. In the next video, we will create the application layer using integration test again. This will be the final layer in our content service. See you in the next one. Goodbye.